Oh man, look at my life, I'm a lot like you were. Oh man, look at my life, I'm a lot like you were. Oh man, look at my life, 24 and there's so much more. Live alone in a paradise that makes me think of two. Love lost such a cost, give me things that don't get lost, like a coin that won't get tossed, rolling home to you. Oh man, take a look at my life, I'm a lot like you. I need someone to love me the whole day through. Okay, hi there. Today, for Algebra 2, I'm going to be covering Chapter 6-3, Binomial Radical Expressions. So, when you're adding and subtracting radicals, it's important to keep in mind that they must have the same index and the same number under the radical. And I gave an example here. You know, if I take the third root of 5 and I add the third root of 5, that's 2 third roots of 5. I can add those together. I can subtract them. I'll give you some examples in this video of ones you can't add and subtract together, okay? So anyway, keep that in mind as we go through this. The first one I'm going to look at is this. Square root of 2 plus the 3 square roots of 2. What we're really doing is adding the coefficients together. So there's an implied 1 in front of that square root of 2, which means I'm adding the 1 and the 3 together, and I get 4, okay? The square root of 2 just stays the way it is. In fact, one way I like to think about these is you can think of a radical as a variable, which means this is really like the same as 1x plus 3x, okay? And I get, you know, that's 4x. The only difference here is the x happens to be square root of 2, all right? So that's a powerful way to think of these, and I would encourage you to keep that in mind as you go through these. Second one, so this one is similar. You know, there's an implied 1 in front of the 5 square root of x, square root of 5xy, which means, once again, you know, you just leave what's under the radical. They match, right? And there's an implied 2 here for both of those, which means, you know, I'm not going to do anything to the 5xy. Leave it under the radical. All I'm doing is adding the coefficients. 1 plus 8 is 9, okay? And that's the answer, and that's as far as you can get. You can't get any of that stuff out from under the radical either very, very easily, so I wouldn't try. Next, same kind of setup, you know. The same thing can be said as this one's the only difference is this has a third root, but the other one does too, so it's okay. You know, I can just leave the third root of 7 as it is and then add the coefficients. 5 and the implied 1 over there gives you 6. 6 third roots of 7. Once again, this is the same as 1x plus 5x is 6x. The only difference is here x is the third root of 7, okay? All right, this one. You know, they keep looking more and more complicated, but as long as the stuff that's under the radical is all the same, you just leave it there, okay? You know, this is the same as x minus 8x, which is going to give me negative 7x. The only difference here is that's a 1, and so I'm going 1 minus 8. That's going to give me negative 7. The only difference here is that the x is the third root of 9x squared y. All right, and that's the answer. So yeah, once again, they're not messing around with what's under the radical there. I can't pull anything out. Those are third roots. You know, the third root of 9, square root of 9 would be 3. That I would pull out. If this was a square root instead of a third root, that would be a different kind of a setup. All right, this one. If I I'm adding these together. So I'm still adding the coefficients, but now I've got x's in there, which means I'm adding 6x plus 4x together. Oh, but there's a problem. I have this different numbers under the radical, which means I can't add these or subtract them together. Can't combine, I should say. You can add them, you can't combine them. I mean, the only thing you can do is leave it as it is. So you just leave it, okay? You can't combine those together. They don't have the same number under the radical. Can't add them. All right, this one. These have different indexes. Once again, I can't combine these. Just because they have the same number under the radical doesn't necessarily mean you can combine them if they're, different indexes, okay? So we just leave it. I would just leave it like that. It's 12 third roots of 7xy minus 8 times 5 fifth root of 7xy. I would just leave it like that, okay? And it's not necessarily that I'd be like putting those on a test trying to trick you. Not that it's never happened, but, I don't generally go out of my way to do that. However, what I see is that students, they just keep combining stuff together. You give them some problem and they don't know when to stop. They don't know that, geez, I can't actually combine those. So that's really where it becomes important. All right, so these, same index, same number under the radical, these I can combine, okay? Which means I'm really looking at, the 4 and the 7 there. 7 minus 4 is 3. And the third root of 5. And I'm just going to leave that just like that. Same as 7x minus 4x. All right, you try this one. 3x plus 4x squared xy on both of them. And here's the answer for you. All right, this one, a little different. So with this, I'm breaking up radicals here. You can't add them the way they are, but those are all reducible. And when you see 75, I'm hoping you're thinking, geez, what's a perfect square that goes into that? Well, 25 goes in, and the square root of 25 is 5. 5 times square root of 25 times square root of 3 is 75. 12, the square root of 4 goes into 12. And the square root of 3, I'll just leave it as is. Which means when I break this down a little farther here, the square root of 4 is 2. So I got 2 square roots of 3. The square root of 5 is, of 25 is 5. So that's 5 square roots of 3. And now, look at that. Now they all have the same number under the radical. And I can add them all together. Remember, and there's a 1 implied in front of that square root of 3. So 2 plus 5 plus 1 is 8 square roots of 3, and that's the answer. And that's nice because they all went together like that. All right, here's another one that's similar to that, except it's third roots. So you got to know your third roots a little bit. 125 is a perfect cube. 125 is 5 times 5 times 5. So third root of 125 times third root of 2. 54 is the third root of 27 times the third root of 2. And, I'm looking at this over here and I'm thinking, gosh, the third root of 2 seems to be the common number there. 2 times what is 16? Gives me the third root of 8. And 8 is a perfect cube also. So all three of those have perfect cubes in them. And now I can break it down a little farther. We said 5, because 5 times 5 times 5 is 125. Third root of 27 is 3. 3 times 3 times 3 is 27. Third root of 8 is 2. So now they all have the same numbers under the radicals, and I can combine the coefficients together. 5 plus 3 plus 2 is 10. Third roots of 2. And that's the answer. All right, next one. Now, we're not that creative. Not everything always goes together either, but I see this square root of 3 over here, and I'm thinking maybe the 3, if I break these up, maybe I'll get square root of 3's out of all of them. So what times 3 is 48? Kind of giving you a tip on how to do some of these. Be smart. And you get square root of 16 times 3 is 48. Now I'm just going to leave that 4 there in the front, okay? Similarly, I'm just leaving this 3 over here. 75, 3 times 25 is 75. All right, so now I can do my perfect squares. Square root of 25 is 5. So I got 5 square roots of 3. Square root of 16 is 4, but remember I have this other 4 here, so I'm going to multiply those two 4's together, and I got 16 square roots of 3 minus 3 square roots of 3. Okay, now I can combine all of these together. I got the 5, I got the 16, and I got minus 3. So 5 plus 16 is 21. 21 minus 3 is 18 square roots of 3. Same as 5x plus 16x minus 3x, right? It's just the x is the square root of 3 in this case. And that's that problem. All right, why don't you try this one? I don't forget if I wrote down an answer for you on this one. You might be on your own. You might have to bring it into class. Negative 3 square roots of 18 plus square root of 75 plus 4 square roots of 32. Yeah, no answer for you. Guess you're doing it out on your own. All right, I'll do the perfect cube though. So perfect cubes that go into 250 once again. 125 times the cube root of 2. 54, 27 times 2. And 16 is cube root of 8 times cube root of 2. So they're all cube root of 2's here. I got third root of 125 is 5 root 2, 3. That should have a third root on it too. Third root of 2, and 2 is the third root of 8. Now I can combine the coefficients. 2 plus 3 plus 5 is 10. Third root of 2's. All right, next one. You try. Why don't you see if you can combine these two? Square root of 125 minus 2 square roots of 20. Nope, no answer for you. You're out of luck. All right, this one. Multiplying binomials. So you do these by FOIL or box, okay? Whichever you prefer. I'll do it both ways just to show you. If I go FOIL, that's 4 times 5 is 20. First, outside, inside, last. Outside would be the 4 times 4 square roots of 2, which is 16 square roots of 2. Plus the insides would be the 2 square root of 2 and the 5. Which is 10 square roots of 2. And last ones would be the 2 square roots of 2 and 4 square roots of 2. When I multiply those two together, 2 times 4 is 8. Square root of 2 times the square root of 2 is 2. Remembering that, hopefully. Okay. All right, so let me clean this up here. I got 20 plus 16 square roots of 2 plus 10 square roots of 2 is 26 square roots of 2. 8 times 2 is 16. Now I can add the 20 and the 16 together and get 36 plus 26 square roots of 2. And once again, leave those. Don't add those together and get whatever. Add the coefficients, get 62 square roots of 2 or something dumb like that. Don't do that. Just leave it like this, okay? All right, next one. You try. Why don't you multiply that one out, please? FOIL or box? Oh, I didn't do box up here. Let me show you box just to prove to you that it comes out the same. So box is this way. So I got 4 plus 2 square roots of 2. Over here I got 5, 4 square roots of 2. And if I multiply this out, I get 20. 5 times 2 square roots of 2 is 10 square roots of 2. 4 times 4 square roots of 2 is 16 square roots of 2. 4 times 2 is 8. 2 square root of 2 times square root of 2 is 2. So you can see you get the same thing here. I can go 20. These two I can add together. I get 26 square roots of 2 plus 16. And you will get the same thing as you got over there. Okay? So there's your proof that either way works. Okay, you choose. I don't care which way. You don't have to do it both ways. Choose box or foil and do it one way or the other. All right, the last thing I'm going to do here is I'm going to do a rationalizing the denominator here. So in order to do these, you have to do a difference of 2 squares with the denominator, which means I'm going to multiply top and bottom by the same thing, but one has to be a plus and one has to be a minus. So because this one's a minus, this one's got to be a plus. Okay, so I got to do this to both top and bottom of the fraction so that I'm really multiplying by 1 and not changing the value. Okay. All right, so believe it or not, that's probably the harder part of this, that students they don't get the beginning part right like that, and then they don't get the answer right. So now it's about just doing all this stuff out. So the numerator is going to be 3 square roots of 2 times the square root of 5 plus the square root of 2. And the denominator is going to be the square root of 5 minus the square root of 2 times square root of 5 plus the square root of 2. Fix that, it doesn't look good. All right, so that's what I get. Now you have to do this out because there's going to be a lot of simplifying that happens here. For example, the numerator, if I multiply this out, the square root of 2 times the square root of 5, those have the same radical. You're multiplying also, not adding. So the square root of 5 times the square root of 2 is the square root of 10, all right? Just so you see where I'm going with this. So this is 3 times the square root of 10. Square root of 2 times the square root of 2 is 2, so this is going to be plus 3 times 2. I was just doing the second part of this distributive property here. Denominator, so that's a difference of 2 squares, which means you can square the front, keep a subtraction sign, square the back. You know, if you didn't like that, you'd be doing foil or box with this right here, the denominator. And either way, you're going to get this here, which is going to be 5 minus 2, okay? Square root of 5 squared is 5, square root of 2 squared is 2. The numerator I'm just leaving like this, 3 square roots of 10 plus 6, okay? But the denominator, 5 minus 2, is 3. Ooh, this can be reduced too, which is good. Room here. Okay, so let's see. This is 3 square roots of 10 plus 6. Notice how all three of these coefficients are divisible by 3. So, you know, what you're really doing is you factor out a 3, which means I got square root of 10 plus 2 is going to be the answer. What you're really doing is if you took the numerator here, and I factored out a 3, it would leave me the square root of 10 plus 2 over 3, and then those cancel out. Or you could just look at those numerators, the 3, 6, and 3, and realize they're all divisible by 3 and simplify it. But that needs to get simplified, especially because I get rid of the denominator. Okay, so that was my last problem. So I'm going to close it out with a little bit more music. You guys have a great night.
And you can tell that's true. eyes, look in your eyes, run around the same old town. Doesn't mean that much to me, to mean that much to you. I've been first and last, look at how the time goes past, but I'm all alone at